Assalamu alaikum, dear students. Dear students, our today's topic है calculation of energy of the electron. Basically, we were dealing with the question that is the Bohrs model of atom. Bohrs model of atom हमने previously video lecture में discuss किया. What are the various these postulates of the Bohrs model of atom? Then we have the calculation of the radius of the Bohr's orbit. Then आज का topic है that's the calculation of energy of an electron. We know that according to the Bohr's theory that electron जो होता है in the atom we have the nucleus, and electron जो होता है according to the Bohr's theory that's present in the circular path, and इस circular path को हम कहते हैं orbit. Orbit में होता है electron and it is continuously revolving around the nucleus. So this electron in this particular orbit, it possesses the energy. On that basis, the orbitals are also called as the stationary states, or these are also called as the energy levels. क्योंकि electron होता है present in these orbitals, it possesses the energy. It possesses energy which is the total energy जो होती है इस electron की total energy, that is equal to the sum of the kinetic energy plus potential energy. तो electron जो है in the orbit, it possesses the energy, and the total energy of the electron is given as the sum of the kinetic energy plus potential energy. Kinetic energy जो होती है electron की, it is because of its motion around the nucleus. It possesses the velocity due to which due to that velocity it has the kinetic energy, and that kinetic energy is equal to 1/2 mu square, where u is the velocity of the electron and m is the mass of the electron. And होती है इसकी potential energy. It is potential energy होती है electron की. It is because of its attraction towards the nucleus, due to which it possesses the energy which is called as potential energy, and that potential energy is equal to k z e square divided by r minus. So you have the energy of the electron, and that total energy of the electron is equal to the sum of the kinetic energy plus potential energy. Kinetic energy is because of its velocity. It is continuously revolving around the nucleus. And potential energy is because of its attraction towards the nucleus, and that is given as minus kz e square divided by r. So we have the total energy of the electron. टोटल एनर्जी जो होती है इलेक्ट्रॉन की, that is E is equal to kinetic energy plus potential energy. Kinetic energy we know E is equal to kinetic energy we know that's called 1/2 mu square plus potential energy. Potential energy किसके बराबर है? minus kz e square divided by r. So you have here E is equal to 1/2 mu square minus plus into minus kz e square divided by r. Now we know that एक force act कर, two types of forces act on the electron. One force is because of it has a negative charge and it is attracted by the nucleus towards itself, and number second is the centrifugal force acting on the electron, and that centrifugal force acting on the electron that is equal लेकिन उसकी डायरेक्शन अपोजिट होती है to that of the electrostatic force of attraction between the nucleus and the electron. So we have during the calculation of the radius, we have seen that equation, that's Fe is equal to Fc. We know that. What is this Fe? Fe is the electrostatic force of attraction, and Fc is the centrifugal force acting on the electron, and that Fe, electrostatic force of attraction, that is given as k z e square divided by r square is equal to m u square divided by r. This 1r and 1r will cancel. It is k z e square divided by r is equal to mu square. यहाँ पर आप देख सकते हो mu square is equal to k z e square divided by r. तो यहाँ पर हम इसका वैल्यू सब्स्टिट्यूट करेंगे या suppose this is our equation first, this is our equation second, and this is यहाँ पर हम लिखेंगे substitute the value of mu square in equation second. इक्वेशन सेकेंड में हम सब्स्टिट्यूट करेंगे वैल्यू किसका mu स्क्वायर का इन इक्वेशन सेकेंड. वी गेट E is equal to 1/2 mu स्क्वायर के बदले हम क्या लिखेंगे k z e स्क्वायर डिवाइडेड बाय r. k z e स्क्वायर डिवाइडेड बाय r वो इसका माइनस k z e स्क्वायर डिवाइडेड बाय r. यहाँ पर आप देखो k z e स्क्वायर in both the cases k z e स्क्वायर that is common, so we can write here. इसको बाहर निकालेंगे k z e स्क्वायर और r को, तो अंदर क्या रहेगा k z e स्क्वायर डिवाइडेड बाय r इंटू 1/2 माइनस 1. क्योंकि अगर आप इसको इसके साथ मल्टीप्लाई करोगे तो वापस आएगी अब एक्सप्रेशन. तो इसको हम सॉल्व करेंगे. क्रॉस मल्टीप्लिकेशन दैट इज 1 minus 2 divided by 2 that is minus 1/2. So here you have E is equal to minus 1/2 k z e square divided by r. So in this expression you know that k is constant, z is the atomic number, that's also constant, E is the charge of electron that we know, and r that is the Bohrs radius, and Bohrs radius we know. r किसके बराबर होता है? r is equal to n square s square divided by 4 pi square k z e square m. ये हमने कैलकुलेशन की है. That is the Bohrs radius. Bohrs radius किसके बराबर होता है? That is n square s square divided by 4 pi square k z e square m. तो हम r का वैल्यू सब्स्टिट्यूट करेंगे इन इक्वेशन थर्ड. This is our equation third. Now substitute the value of r in equation third. Substitute the value of r in equation third. We get E is equal to minus 1/2 k z e square divided by, तो यहाँ हम नीचे लिखेंगे that is n square s square, ये ऊपर चढ़ेगा that is 4 pi square k z e square m. अब देखो कॉमन जो है वो कैंसिल हो जाएगा, that's 2 1s are 2 2s are 4. So you have here that C is equal to 2 minus 2 k and k pi square 2 pi square k square z square e4 m divided by n square h square. This is the expression for the energy of the electron. So you have energy of the electron. Electron जो होता है in the orbit that possesses the energy, and that energy is equal to the sum of the kinetic energy plus potential energy. Kinetic energy is because of its velocity of the electron, and that is given by 1/2 mu square, plus potential energy because of its attraction with the nucleus. As the electron, when the electron is present at infinity, there is no attraction between the nucleus and the electron, and hence that potential energy is set at 0. But as this is the nucleus and this is the electron, as the electron is coming towards the nucleus. There is a force of attraction between the two, and the energy is released. That energy is given as the potential energy of the electron, and that is equal to minus kz e square divided by r. So here you have the potential energy, kinetic energy of the electron, that's 1 by 2 mu square plus potential energy of the electron, that is k minus kz e square divided by r. So we know that electrostatic force of attraction is equal to the centrifugal force acting on the electron, and that is given as kz e square divided by r square is equal to mu square divided by r. So here we get the mu square is equal to kz e square divided by r. फिर हम इस mu square का जो वैल्यू है इसको हम सबस्टिट्यूट करेंगे इन इक्वेशन सेकेंड. We get that is 1 by 2 kz e square divided by r minus kz e square divided by r. फिर हमने इसको सॉल्व किया तो यहाँ से हमें निकली एनर्जी की एक्सप्रेशन, दैट इज E is equal to minus 1 by 2 kz e square divided by r. But here in this expression we know that k, that's constant, z is constant, E is the charge of electron, and we know that r का value हमें पता है, that is m square s square divided by 4 pi square kz e square over m. फिर हमने r का वैल्यू सबस्टिट्यूट किया है in the equation. we get what? The energy of the electron. अब इस expression में आप देखिए, that is 2, that's a constant, pi is constant, k is constant, z atomic number constant, E charge of electron constant, mass of electron constant. What is varying? That is the number of shell n, and h, that's Planck's constant. And here when we substitute all the values, we get E is equal to 21.8 into 10 to the power minus 19 joule per atom divided by n square, यहाँ पर है multiplied by z square. This is the energy of the electron. Or we can say we have the energy when we substitute all these values. For the hydrogen atom we get, for hydrogen atom, energy of the electron is, for hydrogen atom, energy is given as E is equal to minus 1312 kilojoule per mole. ये है for hydrogen atom, and for hydrogen like species we have minus 13. For hydrogen like species, E is equal to minus 1312 divided by n square z square, यहाँ पर kilojoule per mole. This is the energy of the electron, and you have to remember this expression, that's minus 1312 z square divided by n square. For nth shell, or for the, suppose for second shell, you have to calculate the energy of the electron. You can easily calculate. For suppose if for hydrogen atom you have to calculate the energy of the electron, if that electron is present in the third shell, we get E is equal to minus 1312 multiplied by 1 square divided by n. n का वैल्यू हम सबस्टिट्यूट करेंगे, that's equal to the 3 raised to power 2. तो यहाँ पर आएगा, that's energy of the electron minus 1312 divided by 9 kilojoule per mole. This is the energy of the electron in case of the hydrogen atom and the hydrogen-like species. Now we have another topic in this, that is the calculation of frequency or wavelength of the electron. This was number first, that's calculation of energy of the electron, and number second जो है, that's calculation of frequency or wavelength of the electron. Another सब टॉपिक जो है इसमें, लेटेस्ट टॉपिक जो है calculation of frequency or wavelength of an electron. Dear students, we know that we have the electron, and that electron, if that electron is present in the, this suppose shell number 1 and this is shell number 2. According to the Bohr's theory, if the electron is present in the ground state, it neither emits energy nor absorbs energy. Now, if we supply energy to this electron, it will absorb the energy and it gets excited to the higher energy levels. So it gets excited here, and in the excited state it remains there in the excited state, and then it tries to jump back to the ground state. When it jumps back from the higher energy state to the lower energy state, it emits the radiation. And we have to calculate the inner frequency or the wavelength of that emitted light. We know that जो ये emitted light होती है, इसने कितनी amount of energy radiate emit की, that is called the difference between the two levels. ये हमने postulate में already से discuss किया है. That is the delta E is equal to h into mu. ये हमने वहाँ से किया है. What is this delta mu? Sorry, delta E. Delta E is equal to energy of higher energy state into minus lower energy state. Difference between the energy levels, the difference between the two energy levels, that is the excited state and that of the ground state, that is equal to h into mu. Mu भी हमें पता है, mu किसके बराबर होता है? C divided by lambda. So here you have E2 minus E1 is equal to h into C divided by lambda. So we can calculate the frequency as well as wavelength of the emitted light when the electron it jumps back from the higher energy state to the lower energy state. We know that energy जो होती है किसके बराबर, that is E2 is equal to minus 2 pi square. अभी हमने calculate करके दिया है this. We have calculated the energy of the electron, that is equal to E2 is equal to minus 2 pi square k square z square E4 m divided by n square h square. But here it is the energy of higher energy state, that is E2 state, there here is n2 square energy. Similarly, we have the energy, the lower energy state E1 किसके बराबर, that is equal to minus twice, instead of n2 here in this expression, in this in case of the energy of the ground state, we have here n1 square. So here you have minus 2 pi square k square z square E4 m divided by n1 square h square. So we have the inner expression for the E1 as well as for the E2. We can easily substitute these values and we get the wavelength or the frequency of the emitted light or radiation. So here you have h into mu. Here you have h into mu is equal to E2 किसके बराबर है, minus 2 pi square k square z square E4 m divided by n2 square h square minus, this is the minus formula का minus into minus 2 pi square k square z square E4 m divided by n1 square h square. So here you have h into mu is equal to minus 2 pi square k square z square E4 m divided by n2 square h square. Minus into minus it becomes plus, that is 2 pi square k square z square E4 m divided by n1 square h square. सो यार यहाँ पर हम लिखेंगे, यहाँ पर आप देखो ये सब चीज़ें जो है यहाँ पर हम ऐसे भी लिख सकते हैं h इंटू न्यू। ये हम पहले लिखेंगे बिकॉज दिस इज प्लस, दिस इज 2 पाई स्क्वायर k स्क्वायर z स्क्वायर e4m डिवाइडेड बाई n1 स्क्वायर h स्क्वायर माइनस 2 पाई स्क्वायर k स्क्वायर z स्क्वायर e4m डिवाइडेड बाई n2 स्क्वायर h स्क्वायर। इस एक्सप्रेशन में आप देखो दैट इज 2 पाई स्क्वायर के स्क्वायर z स्क्वायर e4m डिवाइड बाई h स्क्वायर, ये कॉमन है तो इसको हम इट इज कॉमन इन बोथ द terms here, so we can write it as h into nu is equal to 2 pi square k square z square e4m divided by h square, और अंदर क्या रहा, that's 1 divided by n1 square minus 1 divided by n2 square here. Now this 2 is constant, pi is constant, k is constant, z that is the charge of the nucleus, that's also constant, e charge of electron, that's constant, mass of electron, that's constant, h is Planck's constant, that's also constant, and इनके बदले हम एक ही constant लिखेंगे that's called the h into nu। या इस h को हम यहाँ भी ला सकते हैं, nu is equal to 2 pi square k square z square e4m divided by h cube into 1 divided by n1 square minus 1 divided by n2 square। तो यहाँ पर इस एक्सप्रेशन में है 2 पाई स्क्वायर के स्क्वायर जेड स्क्वायर e4m डिवाइड बाय h क्यूब, ये कांस्टेंट है, इसके बदले हम एक ही कांस्टेंट लिखेंगे दैट्स r। तो न्यू इज इक्वल टू r इंटू 1 divided by n1 square minus 1 divided by n2 square. What is this r? It is called as Rydberg's constant and its value is equal to r is called Rydberg's constant and its value is equal to 109,678 centimeter inverse. So if we substitute the value of the Rydberg's constant, then we have to calculate the frequency or the wavelength of the emitted radiation. We can easily calculate it out, provided we should know where from the excitation takes place. If the excitation takes place from the energy level, from the higher energy state, suppose n2 to n1, here we can write 2 square and here it is 1 square, then we multiply it with this, we can easily calculate the frequency or the wavelength of the emitted radiation. This was about the calculation of energy and the frequency of the emitted light or energy of the electron, वो हमने calculate किया, how to calculate the energy of the electron. Then we have the calculation how to calculate the frequency or the wavelength of the electron. यहाँ पर हमने frequency calculate करके दी, हम wavelength भी calculate करके दे सकते हैं, that is simply इसके बदले हम क्या लिखेंगे c divided by lambda, और यह c यहाँ आएगा division में आएगा, there is 1 divided by lambda is equal to r divided by c. So here you have in case of wavelength, we know that lambda frequency किसके बराबर है, 1 c divided by lambda. So here you have c divided by lambda is equal to r into 1 divided by n1 square minus 1 divided by n2 square. So here you have 1 divided by lambda is equal to r divided by c into 1 divided by n1 square minus 1 divided by n2 square. This is the calculation of the frequency and the wavelength of the emitted radiation. Inshallah, in the next video lecture, we will go through the spectrum, absorption and emission spectrum. Thank you so much.